our heads around this draw history graph from Snapshot graph. Concept. You've got a question. The figure shows a snapshot graph, so which is a function of displacement in the x direction and time, taken at time equals 2 seconds. If a pulse of a pulse traveling to the left along a string at a speed of 2 meters per second. Draw the history graph, the graph that's a function of the point that is at -2 meters, this point, and time of the wave at the position x equals -2 meters. So we're caring about the point at this position. Okay, so how are we going to start? Well, we're going to draw a set of axes. And here we're going to have displacement. Now we're drawing a history graph. We're drawing a history graph. So we know we're going to have our displacement in the y direction and time, and that's going to be in seconds. And then we're starting. This snapshot was at 2 seconds, so we actually have to start our history graph at 2 seconds. Okay, so what's going to happen? Well, wave's traveling in this direction, and so after 1 second, where is the wave? And that will be at t equals 3. I should actually probably call this is 3. After 1 second will be at time equals 3 seconds. So t equals 3. The wave's it's moving 2 meters per second, so it moves from here and it's gonna move 2 meters. And so it's gonna look like this. Okay, so we're plotting the point. So I could say history of the point x equals -2. So we're looking at this point here. We're looking at this point here. So the question is, has this point moved at 3 seconds? Well, the answer is no. At 3 seconds, our point is just here. Okay. Next. After another second, we're still moving this way. We've moved from here. And so in the next second, this wave crest is going to move another 2 meters. So we're going to look like, our wave's going to look like this, isn't it? After another second, which will be t equals 4 seconds. So we're here, 4, and our point is now here, which is at 2 millimeters. So I can do that. I can say that's 2 millimeters, and I can say our point is now here. Great. And in between here and here, we know it wasn't anywhere until suddenly it jumped up to that point. So we can go like this, draw along there, and then we can draw up here. Okay, what about after another second? Well, at t equals 5, for example, where's our point? T equals 5. Well, after t equals 5, we know our graph's moved because it moves 2 meters every second, another 2 meters. So our pulse is going to look like this. We've moved this initial waveform, and it's going to look like this. That's at our t equals 5 seconds. So the point is kind of here at 2. It is at 2. But it also is at the same time kind of at -2. So we're seeing a jump. So we're going to see something along these lines. And in between, the point just stayed there. The point just stayed there as this whole pulse kept it that high. So we can join that up. Okay, and so that's time equals 5 seconds. And then finally, pick another color. Extend this out a bit. After at time equals 6 seconds, it's going to be here. this is the point, -6. We know that our wave crest, or our pulse, is going to move another 2 meters. So it's going to look like this. Okay, so what's happened to our pulse in that time, or what's happened to this, our particle at the position x equals -2 during that time equals 5 seconds to time equals 6 seconds period? Well, it was here, and then as this pulse moves, it would travel kind of along this line. So it's going to start here, and it's going to gradually move back here at a constant velocity. So we know we're tracking back from here to a displacement position of 0. And from then on, there's no suggestion that there's any more of this pulse back here. So we can just assume that from 6 seconds onwards, our particle remains at y direction displacement of 0 millimeters. So essentially that's how we draw a history graph from a snapshot graph. We just have to walk through it. It's helpful to draw the waveform and how far it moves. We step through in seconds or half seconds, depending on the shape of the waveform, and say, after 1 second, where will this particle be? After another second, where will this particle be? And we could see from 2 to 3 seconds, the particle doesn't move. From 3 to 4 seconds, the particle pretty much doesn't move, but then at 4 seconds, it just jumps up when it hits this point. And then it's going to stay here for another second. It's going to move. Then it's instantaneously going to move down to the maximum negative displacement of -2 millimeters. And then it's going to, within the next second, going to make its way back up to its displacement, y displacement of 0. So hopefully that's helped you get a bit of a better understanding of drawing a history graph from a snapshot graph. This question was originally from this website here.